Good evening to one and all. So I hope you guys been practiced those works that have been given to you in the past few sessions. You remember about those ducting and those kind of stuff. So probably we've been completed those topics. Now we will be moving to a little bit more oriented to the practical side knowledges, which means now we completed the drafting related stuffs, isn't it? Especially the placing of diffusers, duct designing, those kind of stuff. But from here onwards, we will be like more oriented to the site aspects. Okay now. So more oriented to site aspects, especially. So let's discuss about those things. First one, we will be going to learn about the duct sheet metal quantity survey. So the relevance of taking sheet metal quantity survey is a part of BOQ design. Okay. So what do you mean by BOQ? BOQ stands for bill of quantity or bill of materials. That's what BOQ. So technically, the BOQ concepts lies to take out the actual number of uh, equipments or elements that should be required for the entire project, which includes from the basic nut and bolts to the maximum sizes of machine. Sorry, what I'm saying is the huge machines, similarly the supportings, uh, and the cables and even the duct supportings and the insulations, dampers, duct sheets, isn't it? So this whole kind of stuff will comes inside the BOQ preparation itself. So initially, once a site is quoted to a certain vendors, they need to provide or they need to give these kind of BOQ information to the client. So once it is satisfied by the client itself, then we can move on to the further works, isn't it? That's how the workflow goes across in a site itself. But however, end of the day, in these workings, the important stuff is BOQ. Okay, now, so according to the BOQ, you need to purchase the items, and these purchased items and the number of items, especially the quantity, price, it's all should be quoted right inside the BOQ itself. Okay, now, so that is the relevance of BOQ preparation. So among these steps, one of important one is meant to be those duct sheet metal quantity survey itself. So why we are using this one? Technically here, we need to know about how much sheets will be required in order to fabricate the entire duct for the project itself. In much more simpler words, we can say what should be the minimum cost of the ducting, and similarly, what should be the minimum square feet area of duct sheets I will be requiring for the entire project. So that's what we are getting from this sheet metal quantity survey. Clear? Okay now. So I hope you got the points. Next of all, how to analyze this one? Actually, if you're considering this kind of sheet metals, especially a rectangular ducts, how to find out the surface area? Sorry, how to find out the area? Technically, rectangular duct means if we consider the area constraint, what will happen? A width and height will be multiplied, which means we got a, as in other words, if you should be using this one across in your if in the same scenario here in this rectangular duct scenarios, you need to use certain equations to find out the actual surface area. Okay, so by analyzing the surface area will give you the exact idea about the actual requirement of sheet for each shape of duct. Okay, so in this scenario, I'm going to show this small equation regarding this sheet metal quantity survey. So the first one is surface area of rectangular duct. So you can see the equation right here itself. 2 into length, which means 2 sides, and width plus height. That's it. What is it? Width plus height. But as in the case of an elbow, we know that elbow doesn't possess any kind of length constraint, isn't it? So in those scenarios, you need to use an equation called 2 into RO into width plus height. Okay. So 2 into RO into width plus height. That means this RO supposed to mean about the inner arc length plus width by 2. So actually, if you consider this rectangle right here itself, you can see the R value, isn't it? The inner fillet length is around like 6 inches, which we've been already drafted right inside our CAD drawings, isn't it? At the same time, once you can see this width, so width means to be this one, isn't it? This is the height actually. So width by 2, which means you will be getting a cutting around the midpoint of the width right here itself, isn't it? Specifically this point. Okay, now. So I think it should be looks like this. The cutting should be looks like this. So the inner fillet, which is like a solid surface, you will be getting something like this, isn't it? So this is meant to be the length of the radius elbow or that elbow itself. Okay, that's how we need to find out the RO value, which is 6 inches plus width by 2. Okay, later, as in the case of an reducer, you can use this equation L into, which is the length into width 1 plus width 2 plus width height 1 plus height 2. Okay, so that is equation for a reducer. Clear, guys? Hello, is it clear? So that's it. Then the reducer length can be found out by the equation change in dimension into 3.5 divided by number of sites reduced. Okay, I think we've been already discussed the reducer length while I've been explaining about those concentric reducers and eccentric reducers. So likewise, here is the same equation that we've been portrayed right inside the slide itself. Now let's get started about the duct sheet metal quantity survey. So before going into that thing itself, we need to understand the basic concepts such as to be the strength of a duct. What is it? The strength of a duct. So how to analyze the strength of a duct? For example, here you can see this is the point that we need to study, which is duct gauge selection. And the first column implies it has to be the largest dimension of duct. If it is below 30 inches, then the gauge of duct that you need to use is a 24 gauge duct. So what do you mean by gauge? Gauge is nothing but it is the actual thickness of that sheet itself. Okay. So gauge, which refers to the sheet thickness itself. Here you can see gauge number inversely proportional to thickness. That means if the gauge number is high, probably the thickness of the duct should be comparatively less. Here you can see for 24 gauge duct, which means 0.7 millimeter thickness of that sheet. That's what I'm saying. So when we need to use a 24 gauge duct, suppose if any dimension of that duct should be below 30 inches, in those scenarios, you need to use a 24 gauge duct. Similarly, if the duct size varies from 30 to 60 inches, either the width or height, that's what I'm saying. Largest dimension of the duct. It doesn't mean to be the length, but it's purely meant to be the width and height. That's it. Okay. So here, if it is lies in between 30 inches, 32 inches to 60 inches, then the duct gauge that you need to use is a 22 gauge, which means we need much more thickness for that specific sheet in order to fabricate for that scenario. Is it clear? Similarly, you can see the remaining steps, which is if the largest dimension of duct lies in between 60 to 90, then you need to use a 20 gauge duct thickness of 1 mm. And if it is above 92 inches, you need to use 18 gauge duct of 1.3 mm thickness. So this is a scenario. Okay. So for example, here you can see a small ductwork that they've been drafted right here itself. So tell me, guys, what is the gauge of that I need to use for this specific duct right here itself? Here the width is 32 and height is 14. So this board, which is the largest dimension, that is 32 inches. So if it is 32, we need to get over with 22 gauge duct. That means here I need to use the 0.8 mm thickness of duct sheet. Okay, now. And similarly, in this scenario, you need to use below 30 inches. Why? Because here the largest dimension is 24 and it is lesser than 30 inches itself, isn't it? So on that area, you don't need to supposedly use larger thicknesses. You can use the standard, which is the 24 gauge duct of a thickness of 0.7 mm. So that's the concept of this duct gauge selection. Now, how we are going to find out these scenarios? For that one, we will be actually having some certain kind of Excel sheets. Okay. So this is a method, this is an Excel sheet that have been shown right here itself. You can see this now. There are a lot of Excel sheets are available. Okay. What I'm saying is, yeah. Here you can see the first sheet is inch to square meter. That means if the suppose if your drawings are in inches, but you should need to probably convert the total surface area, that is the square feet value, into square meter, then you will be using this kind of approach. And similarly, with the standard way, which is inches to square feet conversion, you can use this sheet. And similarly, millimeter to square meter. You can see millimeter to square meter. That means if the entire drawing is in millimeter, then you need to convert the value into square meter itself. That is the standard way. So it's like it is meant to be purely metric and this is purely imperial and it's like some kind of imperial to metric. That's it. Okay. However, end of the day, you will be getting the actual amount of duct sheets required for the projects. So let's discuss the scenario right here itself. Here, I've been already done this one. Here you can see, yeah, not this one. Let's check on to this one itself, guys. So here I've been prepared something like this. This is the same thing here also. You can see serial number, duct in inches. So you need to mention the width, height, and even the length of the duct. So the length of the duct, you need to portray it has to be in inches. Okay, but however, I've been added a column like randomly right here. It's not, no need to do that stuff. Then duct, that means type of duct. If it is a straight duct, branch duct, collar duct, similarly, that's it. Then this is the area and which kind of surface area, beg your pardon, which kind of gauge that I need to use according to the consideration that we've been already looked through those slide itself. Okay, let's discuss how to do that stuff. So first of all, for this scenario, you can see I've been already completed my ducting for Maurya project. Here you can see this now. Okay, so whatever I'm trying to say, it has to be initially we need to collect data according to the drafting itself. So how to do that stuff? It's very simple. First of all, the first one, straight duct one. So that's what I've been mentioned right here itself, which means this is the duct that I'm going to consider initially. So what is the type of duct? Straight duct one. What is the width and height of the duct right here itself? Okay. You've been already mentioned those values right inside your drafting itself or drawing itself. 30-inch width and 14-inch height, isn't it? So the height we got around like 13-inch height and 14-inch height itself. So 13-inch width and 14-inch height. Just enter the value right here itself. You can see I've been entered the value. And later we need the length of the duct. Why? Because it's a rectangular duct. So specifically it will have this length, isn't it? So how to take out the length? It's very simple. Use dimension linear command. According to your drafting, that's how you will be getting the length of the specific duct. You can see it's around like 8 feet 3 inches. So I've been enter the value right here. It's around like 8.2 feet. Then we need to convert the value into inches. Then only we can use these equation, use this value inside the surface area equation itself, because the other variables are in inches and if the length is mentioned in feet, we can't do it directly. So that's why I'm converting the value into inches right here itself. All right, guys, is it clear? Okay, I hope you got the point. And next of all, it's about the length. So what we got, 8.2. Now I'm going to convert the value into 8.2 into 12 inches, which means the reason behind that, 8.2. Click the cell into 12 inches. So these values should be converted into inches itself, which is around like 98.4 inches. That means the total length of these specific rectangular duct should be around like 98.4 inches. Later, it's about the equation. So what is the equation, guys? In order to find out the surface area of a rectangle, the equation is 2 into length, which means you need to create the equation, put equals initially, and after that 2 into length. That means in inches, not in feet. Okay, so 2 into length, 98.4 into, open the brackets, width plus height. That means 30 plus 14. That's it, guys. Just close this one. Now you get a value of like 8,659.2 square inches, isn't it? What is the value we got? It is in square inches, but we need it in square feet, isn't it? So how to convert the square inch value into square feet? Just divide it by 144. That means we know that 1 feet equal to 12 inches. That means 1 square feet equal to 12 cross 12. That is 144, isn't it? So just divide this value with 144. That's it, guys. You will be getting your value. Okay, so 60.133. And according to the size, we know that this is 30, the largest dimension, while comparing with width to height, it is 30 inches, isn't it? So you can directly enter the value. It has to be 24 gauge. But normally, you don't need to concern about these factors. You can see there are a function called if, isn't it? So this is if function doesn't, sorry, probably you will be having this kind of sheets from your company itself. So here they've been created the if function and function. So a lot of stuff, the Excel kind of stuff. So this portrays nothing, but we studied right now about this now. That's what they mentioned. Suppose according to this sheet right here itself, if the value goes beyond like this way, then here you need to enter value automatically has to be 24 gauge. If it is between 30 to 60, then it should be the value like 22. So similarly, they do the same thing right here itself with the help of some kind of if function. So you don't need to concern about that factor. But however, we need to enter those values manually if you need to create a new column, sorry, new sheet like this. And later, it's about the other one. So now we completed for the initial straight duct right here itself. Now, next of all, it's like a branch duct going from a Y-piece connection, isn't it? So in this Y-piece connection, again, the same stuff, guys. Take out the length from each and every angles, which mean the length of the branch duct. That's what I'm saying. For this one, the length of the branch duct is 19 feet 6 inches. And the dimension of the duct should be 18 cross 14, isn't it? 18 cross 14. So that's what I mentioned. I just entered the value in feet and converted into inches. And later I got the surface area value for those straight duct and directly convert the value into surface area by dividing it with 144. Okay. So guys, is it clear now? I hope it's clear. Is there any doubts on this one? No, isn't it? Hello? Is it okay? Is it good though? Hello? Hello, guys. Tell me, is it clear or not? Hello? Are you there? Hello? Okay, fine. Oh, all right, guys. So that's it. So eventually, you need to find out the other length of the duct in order to find for the branch duct 2. Okay. So here the concept is very simple. You need to take out the each and every surface area for the entirety of the duct that you've been drafted according to the project. Is it clear? Okay, now that's it. Later, it's about the other aspects such as the collar ducts, dropper ducts. We need to find out the value for them also. So how to find out those steps? It's very simple though. Initially collar duct 1. What should be the width? You've been already mentioned those stuff right inside the drafting itself. 14 cross 10, isn't it? So enter the value 14 cross 10. So in this Maurya project, typically whole collar ducts are same CFM and same sizes. But the problem is it's there about length. So that's why I've been mentioned those individual values. I will explain that one laterly. Okay. So here you can see collar duct should be calculated like this way, and you will be getting the same surface area value for each and every collar ducts. That's it, guys. So initially you need to calculate for straight ducts, and after that it's about for the fittings. So the first fitting that I will be having right inside my project is the Y-piece connection, isn't it? So in this Y-piece, you can see one side of the Y-piece looks like a elbow, and the other side should act as like a straight duct, isn't it? So here also, The calculation is very simple. For Y-piece connection, I've been splitting these values into two, like straight duct one and uh, elbow one. Okay, straight duct and elbow. That's it. For the straight duct scenario, what is the size of the straight duct, which is the remaining stuff? It should be same as per the upcoming duct to that side itself, isn't it? That is 18 cross 14. That's what I mentioned, 18 cross 14. And the length of the duct, which is the length of the Y-piece connection, around like 2 feet 11 inches. So approximately like 3 feet distance. That's it. Okay. Then converted the value into inches. Found out the rectangular surface area. Why? Because it's like I've been considered it has to be a straight duct, isn't it? And then eventually I got the surface area. But as in the case of an elbow, we know that elbow doesn't possess any kind of length. So in those scenarios, we need to use this equation. What is it? R inches plus width by 2, which is 6 inches plus width means 18 divided by 2. That is 15, isn't it? 15 inches. Directly, we got the value as to be 15 inches length. That means the RO value. It's not meant to be the length. It is the RO value, R0 value. Now we got the whole aspect, isn't it? As per the equation, what is it? 2 into R0, which is 15, into, open the bracket, and width plus height. That's it. Close the bracket and put enter. You will be getting the value 960 square inches. Have been converted the value into square feet. You got it around like 6.6, isn't it? So in the previous straight duct, we got around like 16 square feet. And for this elbow piece, we got it around like 6.6, isn't it? Add these both values, which means here it comes around like 22.6. That is approximately 23 square feet of duct is required, or duct sheet is required to fabricate this entire Y piece right here itself. Okay, is it clear? Is it clear, Avinash? Okay, okay now. Hello, is it clear, Avinash? I hope it's clear. And once it's done, we need to calculate again the dropper sizes. Here, we studied that each and every inner neck size is having 12 cross 12, isn't it? So probably that should be also equals. That means 12 cross 12. The width and depth. Here it doesn't meant to be the height. Okay, now that is meant to be the depth itself. So the width and depth is same itself. 12 cross 12. Then it's about the length, which means the height of the collar. So what about the height of the collar? Here, this is the concept. So what is the, yeah, here you can see, this is the entire length, isn't it? That means BOB to false ceiling is around like 18 inches. In between this distance, we got 2-inch clearance on top side and 2-inch clearance on bottom side. That's how we got the main duct height has to be 14 inches. And around this 14 inches, the collar duct height is 10 inches. That means once again, here among this 14, 2 inches top side and 2 inches bottom side, isn't it? That's how you got this 10 inches height offset. Beg your pardon, 10 inches collar duct height, isn't it? That means now you will be having 2-inch clearance on this side, isn't it? Now you will be having 2-inch clearance on this side. Am I right? 2 inches clearance on this side and the remaining 2 inches side on this side. So total it should be 2 plus 2, 4 inches. So the total dropper length should be around like 4 inches. Okay, around like 0.5 feet. Okay, that's it. Is it clear? That's how we calculate the value. So here they've been considered the length has to be 4 inches. You can see this now. Then apply this equation. Length into width 1 plus, sorry, I'm gonna open the bracket. Width 1 plus, width 2 plus, with height 1 plus, height 2. That's it. Close the bracket. And we will be got the value around like 224, isn't it? So 224 square inches, that's the got, isn't it? 224 divided by 144 will give you the exact surface area, which is around like 1.5 square feet area. Sorry, guys. This is for the shoot piece connection, I think. Sorry, this is for the dropper duct. Dropper duct we got around like 16, 16 square feet. This is for the dropper, guys. Okay. This is for the dropper duct. Okay, now, sorry, beg your pardon, guys. Actually, it doesn't have any kind of dropper right here itself. Okay, now, beg your pardon, reducer. But here, why I've been entered it has to be a reducer. Why? Because you having a shoe collar, isn't it? Actually, shoe collar, which means it's a kind of reducer itself, like a one-side reducer, isn't it? Eccentric reducer. We know the size of the reducer. That means one mouth should be 14 inches and the other should be 18 inches. Why? Because 4 inches offset. You remember? So probably it should be 8 inches. 18 inches. Okay, now. So that's what I mentioned right here itself. Yeah, here I've been considered not 14. Here it should be considered as 16 inches. You remember, it's not 14. They've been taken. Here it is taken. It has to be, yeah, I'm going to change it now. 14. Okay, now. So for dropper duct, you need to add up the whole values. Hello, beg your pardon, guys. Once again, I will make a small correction on this one. In this dropper duct, especially for this case, these two lengths, you can see this now. These two lengths, which means the clearance lengths, that is meant to be the dropper size. So probably the dropper size is around like 4 inches right here itself, which is the height of the dropper. Then you need to use this equation 2 into. Why? Because it's also a rectangular duct itself, isn't it? That's it. So 2 into length, that means 4 inches. Sorry, 4 feet. That's we call this. Beg your pardon, it's 4 inches directly. So 4 inches, which means 4 inches divided by, sorry, 4 inches divided by, how much is that? Sorry, into 12. Yeah, it's directly in the switch. I'm going to beg your pardon. It's the value, exactly the 4 inches itself. Don't need to convert the stuff right here itself. So 12 inches plus 12 inches, which is the width plus depth. So 2 into 4 inches into width plus depth. That is 12 plus 12. So we got around like 1152. Then we having 6 number of droppers. Why? Because 6 diffusers are here, isn't it? That's why I've been considered it has to be 6 number of dropper ducts. Then after that, convert the value into square feet. We got around like 8 square feet right here itself, isn't it? Okay. All right, guys. Is it clear? Hello? Did you got this point? Hello?
Sir, can you repeat once again? Can you repeat?
Proper, isn't it? Okay, let's look here,
Yeah.
guys. Actually, we having 6 number of diffusers, isn't it? So here I've been shown like grills and FAB. No need to concern. Have been considered it has to be an entirety of diffusers itself with full of dropper connection. So probably 6 number of droppers will be there, isn't it? So in those droppers, we need to find out the length. So here, dropper meant to be a vertical duct, like it will goes downwards, isn't it? So the length of the dropper duct, it should be depends upon the clearance area that you've been provided. So among this plenum area, you've been provided the clearance has to be 2 inches on top side and 2 inches on both bottom side. That's how you got 14 for the duct height, isn't it? But as in the case of collar duct height, it should be like 10 inches. That means from the main duct height, you should be considered 2 inches on top side, 2 inches on bottom side. That's how we got 10 inches height, isn't it? So specifically, this means here you'll be the remaining height of the dropper duct should be 2 inches plus this clearance 2 inches, total 4 inch. That's it. Then apply this value right onto the equation. You'll be getting the exact value, which means 2 into length, that is 4 inches, into 12 plus 12 into 6 number of dropper ducts. That's what I mentioned has to be 6. Then convert this value directly into square feet. Okay, convert the value directly into square feet. Will gives you around like 8 square feet of duct is required to fabricate for the entire stuff for this 4-inch distance. That's what we got. Okay, if you increase the length, obviously the surface area also will increase. Okay, now then suppose you having a reducer or a shoe piece. I told you here, however, we've been connected all kind of uh, collar ducts, mostly with a shoe collar reducer itself. So probably the length of the shoe collar should be depends up. Sorry, the length of the shoe collar, which means what? The 4-inch offset, isn't it? This 4 inches is meant to be the shoe collar distance. Am I clear? This is the 4-inch offset. Do you remember, guys? This is a 4-inch offset. You can see 4-inch distance. So this is meant to be the 4-inch distance. What is the new size? New size, which means, adding 4 inches along to this value, which is around like 12 inches. Sorry, this is around like 16 or yeah, it's like 14 inches. 1 feet plus 2 inches. That means 14 inches width plus 4-inch extra. That means 18 inches. Am I right? You can measure it directly like this way. You'll be getting 18 inches, isn't it? So that's it. So that is the two widths you will be getting. The first width should be 14 inches and the second width should, sorry, the first width should be 14 and the second width should be 18 inches. Okay. And enter those values right here itself. 20 width and 14-inch height, and height should be 10. That should be same itself. A small problem here, it should be like 18. Okay. Fine. 18 inches width to 1, 14 inches width to 2, and the height should be same itself. Why? Because it's an eccentric kind of shoe collar. So probably you will be having same heights, 10. Then the length of the reducer, again that 4 inches itself. So directly apply those values. You will be getting the value directly in square feet itself. Okay, that's it, guys. Now you need to add up the whole values, which means for the entire project, you got some kind of square feet, isn't it? So you need to add up all these values. Once again, guys, here you can see most of these ducts are 24 gauge duct itself. But here you can see in this some scenarios, suppose you got your value something in 22 gauge. Now in these scenarios, you need to segregate the values. So what I'm saying is, these surface areas you got according to the gauge, isn't it? Like 24 gauge, 22 gauge. You need to segregate those values separately and you need to add the whole values like 24 gauge, total surface area, 22 gauge, total surface area. And you need to segregate in different cells itself. But in this project, mostly the whole gauges, it should be 24 itself. That's it. That's why I've been done like this way. Okay. Then add up the whole values. You need to consider like 15 to 20% of scrap. So why we are portraying it has to be a scrap? Scrap is nothing but if you cut these, if you cut onto this fittings, especially like this shoe collar, white pieces, probably some amount of pieces should be wasted, isn't it? That's why we need to consider scrap amounts. So here I've been considered scrap amount has to be 20%. Okay. So here you need to find out the scrap value from this specific total square feet itself. Once again, guys, which I told you right now itself. Now, if you got 22 gauge, 20 gauge, 18 gauge, 24 gauge, you need to find out the whole values differently. And for them also, you need to provide this scrap FOS. Okay. So later, I got the value around like 81. Then add this value along with the total square feet, which gives around like 488.16 square feet itself. That means in order to fabricate the entire duct right here itself, I need around like 488 square feet of duct sheet of 24 gauge thickness for the entire project. Okay. So this is the value that you will be accommodating right inside the BOQ. And then once again, here, now we only got the total surface area or the square feet itself, but we might need to know what should be the probable number of sheets required or the number of sheets I need to purchase from the market itself. So how to calculate that value? Generally, a single duct sheet dimension is approximately like 8 cross 4, which means 8 feet length and 4 feet width. That's how you can purchase an duct sheet, generally a GA sheet from the market itself. So this is like a SMACNA standard value itself. That's how they've been selling these arounds. So one sheet area is around like 32 square feet. That means 8 cross 4, isn't it? 32 square feet. Then what about for the entire project? It's very simple. 488 divided by 32, which will give you 15.25. That means approximately 16 sheets I will be required in this project to fabricate this entire ductwork right inside my project, including my straight ducts, fittings, and these kind of, reduces whole kind of stuff. Okay. So this is the important topic. Once again, this is meant to be duct quantity sheet metal survey. Okay. Then later, eventually, you need to find out the acoustic insulation and thermal insulation. So how to find out the acoustic insulation? It's very simple, guys. You will be getting this area, isn't it? That means very simple. Just consider this value, 8 feet 3 inches. And we already found out the area of this Y piece, isn't it? So just add the surface area of that Y piece and this main duct height, sorry, this main duct, and eventually this small connection from here to here. That's it. That's around like 3 feet 10 inches. That means here we know the size, 18 cross 14, isn't it? So 18 cross 14 is as per the equation, 2 into length. What is the length of this duct? What is the length of duct, guys? We got around like 3 feet 10 inches, isn't it? So 3.8 into 12, 45.6, isn't it? Now use this equation, 2 into length, that is 45.6, into width plus height, that is 18 plus 14, isn't it? That is around like 290, so 2981 point something divided by 144. Will give you approximately 20 square feet, isn't it? What is the remaining area for this specific side itself, for the specific piece? Around like 20 square feet, isn't it? So 20 square feet plus then the other values, especially here, the main duct value and the Y piece value. What is the main duct value? 60 square feet, isn't it? So we need 60 square feet plus this 20 square feet plus, sorry, 60 plus 20 plus then the Y piece, total surface area of Y piece is 22, isn't it? That is around like 103. So actually we need around like 105 square feet of acoustic insulation for the project. Okay, clear? That means you need to purchase a 105 square feet amount of sheets of acoustic material, especially those nitrile rubber material. That's what I'm saying, for that entire project. And the remaining area should be considered as the thermal insulation itself. That means add up the remaining values, will give you the exact thermal insulation value for the entire project itself. Okay, so I hope it's clear. Is there any doubts on this one? No, isn't it? Hello? Is it clear, guys? Hello, guys. Am I audible? Hello?
Thermal insulation.
Ah, thermal insulation എന്ന് വെച്ചാൽ എന്തുവാ? ബാക്കിയുള്ള എല്ലാ ഡക്റ്റിന്റെയും സർഫസ് ഏരിയ ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ എന്ത് കിട്ടും? തെർമൽ ഇൻസുലേഷൻ കിട്ടും. മനസ്സിലായോ പറഞ്ഞത്?
Okay.
ഒന്നുമില്ല, എല്ലാത്തിനും ആഡ് ചെയ്യുക. ഓൾറെഡി നമ്മൾ കണ്ടുപിടിച്ച് വെച്ചിട്ടുണ്ട്. ആ വാല്യൂ എല്ലാം കൂടി പ്ലസ് ചെയ്ത് കഴിഞ്ഞാൽ എന്ത് കിട്ടും? തെർമൽ ഇൻസുലേഷൻ കിട്ടും. നമുക്ക് എക്സൽ ഷീറ്റ് ഉള്ളതുകൊണ്ട് കുറച്ചും കൂടി ഹെൽപ്ഫുൾ ആയിരിക്കും നമുക്ക് വാല്യൂസ് എടുക്കാനായിട്ട്. ഓക്കെ അല്ലേ? അപ്പം ഇത്രയുള്ള എന്ത് ഡക്ട് ഷീറ്റ് മെറ്റൽ ക്വാണ്ടിറ്റി സർവേ. Once again, guys, if suppose someone asking you a question like that, I'm having a duct of 42 inch thick, 42 inch width, and 18 inch height. Okay, sorry, 12 inch height. Okay, 12 inch height. So what should, and the length of duct is around like 10 feet. Okay, what is it? 10 feet. Now, how much number of sheets I will be requiring to fabricate the entire 10 feet duct? How you calculate this one? Very simple. Use this equation simply. 2 into length. So 10 into 12, which means 120 inches, isn't it? Into 42 plus 12, isn't it? Divided by 144, which will give you 90 square feet. That means a 90 square feet of sheet is required to fabricate this 10 feet lengthy duct, which having a width of 42 and a height of 12 inches. In much more precise, we can say 90 divided by 32, which is a single sheet dimension or a single sheet area, which is around like 3 sheets, isn't it? I've been required 3 sheets to fabricate this 90 square feet duct for 10 feet distance. So is it clear? So this is the basic typical thumb rule to find out this stuff itself. So I hope this duct sheet metal quantity survey is clear. Okay, ne? Okay, le, makle. Hello? Is it okay? Hello? Is എല്ലാവർക്കും പുരിഞ്ചുതാ എന്തോ ഒരു കാൽക്കുലേഷൻ ക്ലിയർ. താനെ എല്ലാവർക്കും? ഷാഹുൽ ഷഫീഖ്. Hello, is എല്ലാവർക്കും പുരിഞ്ചുതാ എന്തോ ഒരു കാൽക്കുലേഷൻ ക്ലിയർ? താനെ? എല്ലാവർക്കും? ഷാഹുൽ ഷഫീഖ്. Hello, is എല്ലാവർക്കും പുരിഞ്ചുതാ എന്തോ ഒരു കാൽക്കുലേഷൻ ക്ലിയർ? താനെ? എല്ലാവർക്കും? Hello, is എല്ലാവർക്കും പുരിഞ്ചുതാ എന്തോ ഒരു കാൽക്കുലേഷൻ ക്ലിയർ? താനെ? എല്ലാവർക്കും? Avinash, Manu, is it all clear? Okay, fine. Now we will be going into the next topic. Okay, now. So this is all about the duct sheet metal quantity survey. Now what I would like to show the BOQ preparation or and how an BOQ should be looks like. Here you can see this is how a typical BOQ should be looks like. Okay, here you can see. So this is the basic concept of uh, bill preparation. So we know that actually, for example, in our home, while we are planning to buy groceries, you will be initially prepare some kind of basic things that you will be requiring for your home, isn't it? Such as to be like tomatoes, onions, and we know that the actual market amount of those materials, such as to be those groceries, isn't it? Like rice, this much. So that is the same scenario here also. So here, initially they are starting with the mission, especially separatedly. You can see supply of nominal capacity air-cooled ductable split AC unit, which consists of a scroll compressor and a copper tube aluminum finned air-cooled condenser with a propeller type condenser fans and an evaporator section with copper tube aluminum filled cooling coils with a centrifugal blower with drive motors. It is a direct drive motor and refrigerant controls like expansion valve. So actually, this is the concept of an entire machine that has been portrayed in the first description itself. And you need to purchase this machine either from Blue Star, Voltas, or Hitachi. So this is meant to be the client requirement itself. Okay. So here this means from which company you need to purchase those machines. And once again, how much number of machines should be required for the project. For example, 5.5 ton, this much quantity, 11 ton, this much quantity. And you need to mention that for each floor. So you can see for second floor, 5.5 ton. For third floor, 11 ton. For second floor, 2 knots for second floor and 2 knots for third floor. 2 ton, 22 ton packaged unit, like a DP emission. So here you need to mention those units and the quantity. That's it. And similarly, the other ones, which is meant to be the small capacity machines, non-centralized machines like wall ceiling mounted, normal capacity, air-cooled high wall split AC, cassette AC, eventually the same stuff, guys. And here also you can see the right stuffs like 110 high wall, how much numbers required, 1.5 ton, how much required, cassette unit, how much required. And similarly, you need to include the shifting and installation of those machines. Okay. That means the total pricing for the equipment installation and the shifting, including the pressure testing and commissioning of entire stuff. Okay. So it should be initially created right inside the BOQ itself. Now we can see the other data such as to be the piping, refrigerant piping, and you need to purchase the refrigerant piping from these kind of manufacturers. It's like Total or Mandu. Actually, there are a lot of companies are available. If the client is requiring you to purchase those materials from a specific vendor or a specific manufacturer, you need to directly purchase from right there itself. Okay, no other exclusion for that. Then you need to provide the size data. It has to be the suction pipes data and liquid line pipe data and how much running meter length of pipe is required for the entire connection. And similarly, the supporting for those outdoor unit, the outdoor unit, floor mounted stand, floor mounting type on terrace, which is meant to be the MS stand. You will be providing for the ODUs now. That's it. And the canvas connection unit. And similarly, the fabrication, installation, testing of sheet metal ducts. So actually, what we've been done in this exact quantity survey is nothing but this one. Here you can see how much square meter of duct is required for 22 gauge GI sheet and what should be required for 22 gauge. Similarly, the other gauges. So according to your project, you need to mention those values right here itself. So here they mentioned in square meter. Suppose you can mention even in square feet also, like 90 square. Total should be 400 square feet of duct sheet is required for the entire project of 24 gauge duct. Similarly for 22 gauge duct, 20 gauge duct. So this is the calculation that we been done right now itself. Okay. And down the line, you can see the acoustic insulation and where you need to purchase the acoustic insulation and similarly the under deck insulation, AHU room wall insulation, which is meant to be the acoustic itself, guys. They've been already provided with the glass wool. That means for acoustic wall insulation, especially for AHU rooms, you need to provide fiberglass. The other concepts are here. They've been underdeck insulation. You can see nitrile rubber with a certain thickness, including the adhesive. Okay. Then it's about the grill connections. You can see aluminum powder coated square grills for supply and return. And the supplier diffuser of both sizes. You can see 600 cross 600. It is means to be the outer neck size, and inner neck size should be purchased according to your need. So in for Maurya project, we got around like 12 cross 12, isn't it? So that's what you need to mention right here itself, like 300 cross 300. And then down the line, collar dampers, other fittings, like you can see GI volume control dampers, PVC drain pipe connection, copper piping cables, sorry, copper piping, not copper cables for electrical connection. You can see this now. 6 core, 2.5 square millimeter copper cable, and 4 core. And you can see these are different aspects, which is nothing but the connection in between the ODU to IDU. That's it. And eventually the other cost aspect for like ancillary works, which the auxiliary works. Okay, then you need to add up the entire cost value. You'll be getting a total project cost, and it should be included with the tax and duties, like means the GST and this whole kind of stuff. And down the line, you need to prove if the client is requiring an AMC, which is an annual maintenance cost. For each year, you need to quote a required amount of price that you can claim from the client itself. So that should be quoted according to each years, like first year, second year. Similarly, you can claim it near like 5 years. Okay. So it's up to the discussion that you've been held upon to the client itself. So sum total, you will be getting a total amount. Okay, now so that's what you are going to quoting to your client itself. So if the client is okay and satisfactory with those stuff, the project will move on. So this is the basic aspect of BOQ preparation. So whatever you're doing, if it is a firefighting or plumbing, what are the things that you will be requiring for the project? That what we are going to including right inside the BOQ preparation. So is it clear, guys? Is the BOQ preparation is clear? Hello? Is the BOQ preparation is clear? Hello, am I audible, guys? Hello, മനസ്സിലായോ എല്ലാവർക്കും? Okay, I hope you got the okay, fine. You got the BOQ preparation. Next of all, we will be heading over to the next topic called fan selection. Okay, what is it? Fan selection. Okay, so let's discuss about fan selection. So what is the relevance of doing fan selection in our project? In a typical mission, however, we know that probably an inbuilt fan, that means the centrifugal blower, that's what I'm saying. An inbuilt centrifugal blower fan should be already placed right inside the mission, isn't it? That is a normal scenario that we know. But down the line, if you discuss much more or if you dig on to this topic in deeply, you will be ending up with some kind of certain problems called as to be pressure drop constraints. Okay, so especially for complicated ductings, mostly in air handling unit concepts, for custom ton air handling units, according to the ducting that you've been provided or that you've been drafted, you need to purchase the fan for them. That means the blower fan. So actually here we are not explaining about the fan, but instead of that, it's about the motor concept. What is it? Motor concept is nothing but the fan motor. How much HP of fan motor should be required for the project? So how to find out these stuff? That's what we are going to discussing right inside the fan selection topic itself. So in the case of fan selection, the first one, it is nothing but here you need to mention, or we can say this, it has to be, it is the actual or it is the pressure required by the indoor fan in order to overcome the entire pressure drop, or even you can call it as to be frictional loss, head loss, static loss, whatever, that you will be experiencing right inside the entire ductwork. So we studied about the drafting of duct, isn't it? We know that this air should be flown across each and every duct, and it might need to end at the even at the extreme tail end of the duct itself. So how to ensure that one itself? You can use this kind of anemometers on the tail ends of the duct, whether you will be having the enough amount of air according to the requirement. So however, we need to assure that the air should be reaching even at the tail ends itself. So in order to do this stuff, we need to eventually start with a calculation. So that's what it is called as to be fan selection right here itself. Okay, so in the fan selection, we need to constrain the farthest distant air terminal from the mouthpiece itself. Is my point is clear? So in a complicated ducting, lot of branch ducts, collar ducts should be going across your floor itself. But however, the constraint that we need to consider is very simple. You need to consider a flow path from the machine mouth to the farthest air terminal. So farthest air terminal means what? How you calculate your farthest air terminal. So that is the concept. So let's discuss these two branches. Here you can see after this branches, for this side, the length of the duct is around like 19 feet 6 inches, isn't it? But specifically for this side, it's like 20 feet 8 inches, isn't it? So however, here the largest duct, it should be probably this one, isn't it? That means this side. Am I clear? Hello? Hello guys, is it clear? Is my point is clear? So the farthest air terminal means to be this one, isn't it? So I might need to assure that the air which comes from my machine will reaches this tail end of the duct right here itself. And we studied that fluids have a property. Whenever a fluid is flowing across a medium, especially like a ductwork or a pipe, whatever, it will lose its speed and flow rates eventually due to the flow itself. It is because the peculiarity that we studied, it has to be whenever this fluid getting contacted with the surface, especially the inner surface of the uh, passageway, that is the duct or the pipelines, gradually a small friction will pop up right inside the surface of that material itself, isn't it? So that is the reason behind this pressure drop occurring right inside the ducts also. So initially in the duct classes, I've been explained that circular ducts having lesser head losses or pressure drops rather than that of rectangular ducts. Why? Because rectangular ducts having more surface area than we compared to a circular duct. So it will induce more surface area, which creates more friction right inside the ductwork. So it's a bit risky. It's not risky. What I'm saying is, it will create more friction drop, pressure drop right inside the ductwork itself. So in order to obligate that, we need to find out the exact HP of fan motor that will be requiring for the project. So once again, guys, initially you need to start over with the flow path itself. So for example, guys, if you provide a pump at the exact, near to that well, you will be getting max flow rates and max pressure from the exact output of pump. But similarly, if you connect the pump delivery port with a certain pipe and you've been extending this pipe to a certain distance, like 1 kilometer, eventually, once these water reaches the other end of the pipe, it will lose its flow rates and it will lose its pressure, isn't it? It is due to the friction. That is the same scenario happens right inside the ductwork also. As if the air flows across this ductwork, it will eventually lose its speed and flow rates. So in order to assure that, we need more boosted fans for this projects, especially for this custom turned air handling units and like for complicated ductworkings also. Okay, so at this times, we need to actually replace the fan motor with a apt one. For that one, we are going to calculate a simple calculation or a simple designing to find out this fan selection for the ductwork itself. Okay. So there are two sides are there. The first one is TSP. So TSP refers to total static pressure. Total static pressure means the static pressure or the pressure drop caused right inside the entire system. So what is meant to be the entire system? It includes ESP plus ISP. ESP means external static pressure. So what do you mean by external static pressure? That means the pressure drop caused right inside the ductwork is referred as to be external static pressure. And what do you mean by ISP? The pressure drop caused right inside the machine is expressed as to be ISP. So once you got these both values like ISP and ESP, you need to add this both and you can simply calculate the TSP value. From this TSP value, you can directly find out the HP of the fan required for the project right there itself. Okay, is it clear? So now acceptably we can discuss about the small uh, Excel sheet. Actually, I've been prepared an Excel sheet for this one. Yeah, we can see right here itself. So initially, you need to start with we need to start with our flow path itself. Once again, guys. So from the past 5 minutes, I've been referring something. It has to be like pressure drop, head loss. So what should be the unit of this pressure drop or head loss? It's quite simple though. While designing our duct, we learned something called as to be equal friction method. You remember? Among this step, I've been explained that the exact pressure drop or the frictional loss that we've been maintaining inside our duct should be zero point 0.1 inch of water column per 100 feet of duct. That means if you're having a duct and it's having 100 feet of length, then the probable pressure drop right inside the 100 feet duct should be around like 0.1 inch of water column itself. Okay, so considerably here also we need to find out the actual pressure drop which caused right inside the flow path itself. So once again, guys, why we are considering the farthest air terminal from the mouth itself? You know, if the air have the if the fan have the capacity to blow the air till to the extent, so gradually it can overcome the other areas also, na? Which means even so, beg your pardon, you can see this is the farthest distance. If this fan can throw the air till to the extent, it can eventually throw the air to this other area also now. So that's why I've been explained as to consider a single flow path itself. So these flow paths should be probably greater than that of our other areas, which means the farthest air terminal. That is the consideration that we got for our fan selection itself. Okay, so tomorrow we will start up with the fan selection topic, and we will be readily go with the next topic. Okay, tomorrow we can get on to the calculation side, and once it's completed, we will be starting over with the uh, piping side itself. Okay, so that should be our upcoming class like yeah, you know, the syllabus is whatever. Fine. So we can wind up our session. Far much we learn a lot of things. So just go around the class once again, guys. So probably this should be our next modules on the upcoming sessions itself. So complete this duct sheet metal survey. And according to you guys, once again, just try to work on with the theorem project also. Don't forget that one. Okay. All right. So let's wind up, guys. Okay. So we can stop our class and we will be continuing tomorrow. Bye.